Hi, Sportster Paul here. We're here with second impression for VisualMill. As before, it hasn't been stable for me, probably because of my Windows 7, and it had a problem on install where it said, well, we can't install one of the two Visual C++ Microsoft libraries because you have it installed already as a newer version. So it bailed. Maybe that's why I'm getting crazy toolpaths and it's changing numbers in the dialog boxes. You can't save. That's part of the deal with the demo program. I can understand that. So I repeated what I did, watched the video I made, and repeated exactly what I did. And now it's a little different. You can see, let's go take a look. I'm in simulation now. We've faced it, and we've done the perimeter, except this used to be green last video. Now it's orange, meaning it's a little further out. It's over 3/10 out, undercut, I guess, but not quite 1,000th. So that disturbs me. I did mess with stuff. See, that's the problem. In simulation, I made sure the simulation accuracy, I can't remember if I had this set there on the first video or not. I went into SolidWorks options and did a bunch of stuff. Anywhere, the ultimate thing that I hated was the blockiness of those 1/4-inch radiuses. So I pretty much pegged the quality for how close. Matter of fact, I nailed it all the way into the red zone here. So it shows nice smooth corners. I thought, I'm trying to clean up. You'll see when we do this pocket, it's going to have inaccuracies in the corners, and I don't know why. A mill, part of the ISO standard for G-code is it can do arcs mathematically. So maybe this program's just being more true than SolidWorks CAM by CamWorks, because it's telling you the true math of the inaccuracies of the toolpaths. But I don't see why here it can't be mathematically perfect. But that's where we're at. So we did that. Oh, I also bumped the units up to 4 decimal places. And you can do that and save the file before you make any toolpaths. You can't even put a work 0 in. It won't let you save after that. But we're pretty close. Now the next project, I figure, let's do those 2 pockets. The one pocket here. Let's get out of simulation so you can see. The pocket that goes to this level right here. And then the remainder, 1.25, 1/8 of an inch or whatever, down here. This is a test part made by my buddy Dave Rui, who is a mechanical engineer, industrial designer, machinist, CAM specialist, used to sell Master CAM, and it's made on purpose to trip up CAM programs, and it's doing a pretty good job. So overall, though, don't be too negative on this. I do like the way this program works and the methods. I just wish it would leave numbers where I set them and not blow up toolpaths, and you might see some of that as we do this, this first pocket. Let's see if we can go there. So it's a 2-axis. Let's get organized. We're in profiling. This is the last thing we did. So now you can say 2-axis. We want to do a pocket. Pretty basic. I have learned, let me move some stuff on the other screen around. I thought about the bottom face. If you select the bottom face, it leaves islands where the holes are pointing up, an inch. So tedious as it is, you got to do and just select the individual. Unlike SolidWorks CAM, so you can see I've done this so many times, I've memorized all the little hiccups. Unlike SolidWorks CAM, it doesn't show you a little darkened blue outline of a closed profile, which is darn handy. I had this one blow up right here where there's not only, there's not only this little fella, but this one there. And you go here, and you go here, and you go here, and that's a closed contour, I know for a fact. I've already generated the tool, right? If we were just starting, we'd say, hey, you got to have a tool in existence. So I've created the tool when I made those earlier ones. And like I say, I just like generating right away. What are you trying to do? Oh, okay, it's doing it all in the top surface. That's pretty good. It has no depth. And this kind of, I don't know, it's got some really cool things for depth. Let's see if I can show you that. Double click on the parameters. That's what you mess with. One of the things I like, cut levels. You can pick this little pick box. This is the coolest thing since sliced bread. Well, I want to tell you where to cut. Cut from up here, that point. Now, where is it? Here, see it says select endpoint? But I don't want to go to the bottom because it'll bomb right through this. I want to go there. And it knows that's 0.625 inches, and it's figured it out for us. Now, let's go through this because maybe it'll blow up like it did all the times I was practicing. It does not like having 0 here. It doesn't like a 0 in either rough or finish, and I have yet to figure out, well, is that speeds and feeds that get set? Maybe we'll look at that real quick when we're done. Let's generate. Okay, so now it's moved the tool all the way down. So it's going to do it in one big hog out, which would probably break the tool on my Avid Benchtop Pro. Nice little mill, but you know, it's a router base, so I got to take little cuts. But no problem, you end up clicking parameters a lot with this. Say cut levels. Oh, no, it's blown up. It's blown up. Let me show you what happened because we had a 0 there. It goes down about 3 feet. It does 2 rapids down 3 feet under the part. And if you simulate it, it'll put giant holes where the tool holder goes through the part. So that took a little bit of messing. Double click on parameters. Realize what does that, what causes that headache, is having a 0 anywhere, you know, they want you to do a rough and a finish. That's just, they've decided, some programmers decided. So let's do half and half and say generate. Okay, so at least now it's not bombing down to Never Never Land. For a couple times I couldn't figure out how to get rid of it. I had to cut this operation out, delete it, and start over. Okay, let's see if it's a little more obedient now with this cut level business. It's got the right depth. It likes to be in the middle here. Okay, so it's doing the rough in one big whack, but I don't like that. I want to go, what, 1/8 of an inch. In fact, we'll do the finishes 1/8 of an inch too. Generate. Okay, now it's kind of looking like you'd like, right? That's pretty cool. But you're not done yet because it's, like I say, I've never seen a program that wants to leave stock down. It's like everything's a roughing operation to them. You would think of, and you know, that's one of the things that got me on a tangent. I say, well, set it 100% finish. Maybe then it'll set this stock to 0. No. So the tolerance is too sloppy, 10/1000ths of an inch. I don't want that. I want 1/1000th. I tried 5/10ths and it blows up. And then this is where sometimes it explodes, sometimes it doesn't. Say generate. I did it. So, you know, sometimes if you set that to 0, I had a situation once. It was set to 0. I went to cut levels and did something over here. And then when I went back, yeah, see, it's a 1 now. I'm pointing at it like you could see me point. It's a 1. And if you generate, then it can't find valid data. It blows up because 1 inch is, you know, the pocket's so small, it'll blow up. So this autofill, you know, it loves putting the number 1. Sometimes it puts it in other places. And then I found, oops, 0.002. Sometimes it just refuses to obey. You gotta do it in a couple whacks. You gotta give it some kind of tiny number, and then, like I say, is this just because this is a Windows 7 obsolete operating system? Okay, I think this is where it's supposed to be. Let's find out. Go up here, say simulate. I kind of like this too. Go to the end, bang, we're there, and compare. Now, this is why I tightened up tolerances in the visual, what do they call it? Image tolerance. There's a tolerance here, simulation tolerance, simulation accuracy, fine. Maybe I'll change to a voxel model. Let's see what happens. Well, if they all created, you have to rerun all simulations. Yes. Let's see what happens. Apply. Okay. So go to end, nothing to simulate. Go to end. Okay, we're in the voxel model now. I don't know what that'll do. Oh, it kind of looks different. Shows blue here. I don't know if I like this or not. It's not acting like I would expect it to act. So that was a bust. Let's go back to simulation, polygonal, how do you want to say it? Yes, we know that. Okay, we know that. Yes, we know that. Go back to setup 1, go to the end, compare it. Okay, at least I'd rather have rainbow colored weird stuff. I'd like to see green. That would mean it's within 3/10,000ths of an inch, a third of a thousandth, either way. As it is, you know, some surfaces it gets perfect, near perfect, right? Once again, is this some deficiency where they can't do the math? They're doing integers and, you know, they get this rounding error that causes a problem? Or is it being more truthful? And, you know, these corners, look at this rainbow of colors. Blue, that means right in the corner here where G-code can do a perfect arc. Can't do an ellipse. You know, it has to make segments for that. But G-code can do an arc. A machine can do an arc. Why is this all rainbowed? I don't know. I've learned the whole point of this is to maybe not bother you so much. You can open up the tolerance. Let's say 4,000ths. Maybe you've got a part and they say, well, we want it 4,000ths. And then you apply that and it's like, oh, but see, it's still, that blue is saying, I guess it's inside. Yeah, it's not over 4, or it would be dark blue. And we can see dark blue at the bottom because we haven't cut the remainder of that pocket. You know, we had to leave this out. But now, just so we can be back where we were, go back to 1, say apply. There's all our funny colors. Why it's orange this time, but the first time I did this, it was green. Don't know. You'd think software would be deterministic, wouldn't you? So there we go. Now, just like with SolidWorks CAM, I couldn't find a way to edit, you know, what they want you to do. Close this. Say 2-axis. We want to do another pocket, right? Simple enough. You would think somewhere here, you know, you can select curves. You can't edit anything. You just got to pick them. Which means I had to go back here with that, make a sketch, use the convert entities. That throws all the black lines onto the sketch from that face. Then come up here, erase this one, and this one. Then select this one, hold the control key down, this one, oops, unselect the face, and then do convert again. Okay, so now it's the tool path will bridge that hole. You know, otherwise it wants to go around and leave a chunk of material down there incorrectly. This one's a little easier. We did this with the SolidWorks CAM, aka CamWorks. Same problem. This one you can just grab and come straight across until it snaps to the other line. Great. Say leave the sketch. It was sketch 7, but I like calling it the kludge sketch for CAM. And I like hiding it. How do you do that? Here we go. Now you can't see it anymore. Now let's go back and start draining the swamp with alligators. So we want to do the pocket to get down to this face. Same deal. You select the face, it'll leave little protrusions where the holes are. So I learned let me think, the way to do this, I'm forgetting again. Oh my God. I think I just had to do it super tedious. Here, oops, come on. Here, 2-axis, second pocket. If it selects face, it's gonna leave protrusions. Oh, I'm sorry. Now I remember. Why did I make the sketch? See, I turned around. I'm getting select curved areas, select sketch. Then you can go here, kludge sketch. Even though it's hidden, you can still select it. Bam. There we go. So it's got all of these sketch 7. Even though I renamed it, it wants to call it sketch 7. Ooh, I should do stuff on screen so you can see what I'm doing. Generate. Okay, so now it's doing the same kind of similar thing. You can tell it's not being accurate because it doesn't run a tool in here. So, parameters. Drag this over so you can see it. Cut parameters. I want it to be thousandth accurate, and I want no stock left. Generate. Now, you see how I put this little loop here? Can you folks see that with my headshot in the way? See, you put this little loop there. And if you go, the other encouraging thing is if you look at the corners, it bothers me that they use a hard segment there, but that's rounded. Why? Because my buddy Dave, who made this part, is a genius, and he didn't make these a diameter of 0.25, same as the tool, because then the tool has to go to a point in space, stop, and then change 90 degrees to do the other wall. You make it 0.26 like he did, and now it's a continuous motion, and it could sweep around, the milling machine can sweep around that curve. So that's happy stuff, right? We're getting closer. So more parameters. Cut levels, see, it has no depth. It also is saying that I guess we can fool it by telling it that the cut location of the geometry is at the top and that the level is 0. It's going to cut that bottom 1/8 of an inch. But that's not really correct, right? It's at bottom, and then let's do that pick trick, because I just think that's the coolest thing. There are things about this program you can love. So now it knows there, and then I won't waste your time leaving a 0 here. It sure doesn't like that. So let's do, what's half? 1.25? 625. 625, 625. And we'll do, and say generate. Will it blow up? Could not find valid data. Why? I know why. Double click, it'll have a 1 where, like I say, I think I might like this program if it would just be stable. 002 I found, if it has a number, it tends to be a little more polite. Look, it actually got in there with that tighter thing. And is it doing two levels? Yes, right? It's doing 2 levels. That's cool. Double click again. I call it carpalware, where you're just clicking the mouse so much trying to get it to do what you want. Cut levels is correct. The thing is at the bottom. It took that. Now try 0 and see if it'll do it. It did. You notice how everything widened out just a little bit? That's good. See, this thing is smart. Disobedient by changing numbers and boxes that you set, but you know, very smart. I better save now. Now's when SolidWorks crashes. And this thing's crashed SolidWorks 2-3 times this morning while I practiced this. What are we doing? Simulate to end. Wasn't that quick? Compare. So going down to the bottom, see, this is pretty exciting. The Z, at least it gets right to within math. It's got that. It's got, some issues here. Where it's got that rainbow as it does arcs. This obviously should be left. That makes sense. And then, the hole here, that's going to be drilled up from the bottom. Same with this one we bridged over. But it didn't change anything like the SolidWorks CAM when before I made the sketch and did all that. It actually did a little gouge up here because I got confused with its automatic feature recognition, which I had more trouble with than it's worth. So I say OK. Oh, that's the toolpath. That's the sketch being lit up as the containing, what do they call it? Control geometry. I like this thing. I really do. All right, get out of simulation. Boy, I feel we should save it now. It's getting ready to crash any day now. OK, so I don't know if this is fair. I guess I could make a pocket here to the edge. What I found was fun to do is say clear the flats. And I'm not sure if this is available in the basic. In the free package, I can almost guarantee you it's not. Select a flat area. There it is. Say yes. And like I say, I just like hitting generate, see what it's going to do for me. Oh, that's pretty cool. But of course, it's taking it all in one whack. It doesn't seem to like to remember much of anything. Once again, I've never seen a program that never wants to cut to the true model. It once again defaults to this 25 thousandths, which is a lot of meat to leave. To them, I guess everything's roughing. Containment, engage per, okay, I guess here's where we fix it. So intolerance, 0. And then here we'll try 0. We'll say generate. Oh, and we got to do one more thing. So that's pretty cool. See, it seems like every time, I guess it's just I'm intimidated by this dialog box changing. I'm so cautious, so I go over and over and over, re-invoking it. Engage attacked, advanced cut, global parameters. Oh, step over. Here it is. Percent of the, no, that's step over. How deep, I guess that's clearing. Z containment, engage retract, advanced cut. Well, there's no arcs really, but we'll do that. Well, this kind of annoys me because it's taking this big, huge thing and I can't say no, go down in several levels. I thought I had this figured out at once. Step over is fine at 25%. Cut direction, cut pattern. Global, the stock I want to leave 0. I guess you could do 5 of these and go down each a little time. Well, let's just let it do its thing. Oh, something's wrong. No, it did it. Simulate, to end, compare. All good. And now it's left these little chunks off where these slants are. So it's mathematically true. It hasn't left little corners. So that's kind of nice. Clear the flat tops. Now go back to the program, say 2-axis. No, it's a 3. But I found 3-axis, not horizontal finishing. Seem to like to do this. I want to finish flat areas, this one and this one. I once picked this one like I did in SolidWorks CAM so that it went down far enough. Let's do that. I think it blows up. Say generate. Yeah, see it's doing stuff there. So we got to go into control geometry and say flat area 3, remove active, generate. Okay. And now it's kind of doing, what you want. It's hogging through. Oh, I've made a mistake. Double click this. Say edit, create a tool. Now you select the ball mill. I learned if you go here first, it automatically changes that. And the flute length, you don't need a lot of flute on this. 7 tool, make it nice and stubby so it's stiff. It's only 1/4 inch. I think that's long enough to get down. It's 625 down there. Down, say generate. See it put in a couple extra. But it leaves big scallops, just like before. So once again, you go to parameters. This we did in SolidWorks CAM, same kind of mentality. It left 0 for the stock. It left tight tolerances, cut levels. Here it's doing 25% of the tool diameter as Z. I don't know why. It's a nice thing, I guess. Let's try, a 10,000th of an inch. And let's go back here. See, just because we changed focus, it made this a 1. Scary. I'm getting used to the bugs. And it's thinking, it's not necessarily dead. It does take a while, just like SolidWorks CAM. This is a more complicated toolpath. Or it might be crashing. Nothing to cut. Okay. Let's go play with this. Parameters. Once again, it went to a stock of 0.002. Cut levels. 10,000th. Cut parameters. Generate. See, it's quick. Why it keeps changing that? Once again, it did. The installation didn't go quite right. It didn't. But like my software buddies, it's Microsoft. It's Memory Leak City. It's, pushing an amoeba and it squirts out somewhere else. So now let's see if we can get it down to true. One last time. Generate. It did it. See, isn't that weird? You can kind of sneak up on it, but you just can't make it 0. Even if you just click and leave it 0, it blows up. But it's wonderful, right? Isn't that wonderful that it did this? And let's go up to setup. Let's go simulate. Let's go to end first. And let's light this up. Look at that. I've learned, come on. you have to turn toolpaths off. And then once again, say to end and compare. Not perfect, but darn close, but between, less than 1/1000th of an inch. But like SolidWorks CAM, it left this big chunk down here, and I beat that with SolidWorks CAM. Can you move the tool? Probably not. Here's how we do that. Okay, and then zoom up. See, it could go lower, right? It's really not bringing that ball mill, I don't think, down. I did figure out how to do that on SolidWorks. This is the furthest I've got. I didn't expect I'd get this far without it crashing. So there's that same problem of that's why I initially did select this area. That's how I fixed SolidWorks CAM. I told it, do this area, down it came. Let's try it, huh? We still got a few minutes. Control geometry, select surface here, yes, generate, and it's not obviously very happy about this. Parameters. Oh, we turned off toolpaths. That might be a factor, wouldn't it? Toolpath visibility. I think it fixed it. It did. Even though it's silly that it's going around the edge and it's already decked and who cares? I don't know if there's going to be a way to fix that, but now it did go down further to the mathematical touch this point, so it's going to make that scallop in the corner mo better. Where is toolpath? Wait a minute. Display toolpath levels. Toolpath visibility. Go up here. Simulate. To end. And it's doing its thing. Compare. Now, see, I think, oh gosh, it is a little sluggish with all these normal, but I'm pretty sure that's a smaller scallop now, and you're seeing the ball mill just go down. We'd need an 1/8 inch. So that's kind of cool. Like the SolidWorks CAM, though, it's got this issue where, because Dave's a genius and he knew this part would trip up CAM, this angled coming in like that, the tool pulls up too soon and it leaves this meat here. It's over 1/1000th. Let's go 4/1000ths. See how much meat we got. Apply. It's over 4/1000ths of an error. 5/1000ths. Apply. Looks like it's under, well, maybe not. Control. Middle button. Boy, is this thing sluggish. Maybe all those things were set to low resolution for a reason. And I've stopped pulling. It's just going by itself. It's got a little buffer here. Does this thing work? All right. So it's still got some issues. Let's go back. I've learned always try to keep things tight so you can see the problem. Otherwise you forget that you loosen this thing up. Apply. There. With SolidWorks CAM, they had entry and exit radiuses, and I just made a real big radius for the entry and exit. And that's the other thing. This thing is going to be plunging that ball mill down. If we do play, well, actually, it's kind of smart. I'm going to sign off now, but I'll work on fixing that. Next show, maybe if I can figure out how to fix this little leftover material. I don't think we can do better in the corner without getting in like an 1/8 inch pencil mill and zinging that in. But overall, not too bad. All that weirdness, I think, might just be me with Windows 7 instead of Windows 10. But it's an intriguing program. And certainly, I think it's a $5,000, that premium that I saw. No, professional level. It's 5. Premium, I think, is like 10 grand or something for mold making, and it does things that I realized I didn't need. But it's 3D. Just the pro level is full 3D, which is why I believe you get all of these cool things to do, which I have to admit, my friend Dave, who made this part, said, you know, if you're going to get a mid-range package, spend more and get full 3D, and you won't regret that. And I think he might be telling the truth. We'll see. So that's today's episode. All, you know, half hour to get 2 pockets, deck the thing, which really wasn't the right way to do it, and get those 2 angles. And that left a little extra meat. But, you know, at least we've kind of gotten over this weird instability where it changes zeros to ones and does all this goofy stuff. So that's today. Next time we're going to go and flip it over. Same deal. I got to quit. I got to go home, turn off the computer. I'll get to this point, and then next time we'll flip it over and shoot the holes. And I played with that today. It's it won't. You can't just say, like CAM works, hey, it's a tapped hole, and it'll do a center drill and the tap drill, and then it'll tap it. Hard tap it, rigid tapping. You've got to tell it, okay, drill it, 2.01, 0.201, you know, center drill it, tap it as 3 separate operations. But I really don't mind that. If this thing was stable, you know, I kind of prefer the fact that, no, I've done everything, just like writing software, you do everything explicitly and you know what's going to happen. So that's it for today. Hope your CAM journeys are fun. Catch you folks in a bit. Bye now.